And before you start groaning, it's really easy. Okay, physics people, don't freak out or anything. Projectile motion is just a parabola. Okay, so let me show you the equation. H of t equals negative 16t squared. So do you notice how it's a parabola? Opening down. Plus v naught t. That's interesting. Plus h naught. So let me tell you what these things are. Okay, first of all, h of t, okay, that is the height equation. That's the height equation, h of t. So it's not an a of x, not area, it's a height. Negative 16, okay, that's because gravity's pulling you down. Parabola opening down. T stands for time. So the t variable is time. We've got t, and then we've got h of t. This is like the y-axis. V naught. Anytime you see that naught, that means initial. So this is initial velocity, and this one is initial height. Okay? So you do have to memorize and get very familiar with that equation. Now the units for these, I'm going to tell you that the height is always in feet, and that the time is in seconds. Okay, feet and seconds. That's why it's a 16. We're not going to do meters ever. Okay, science people, listen up. We're not going to do meters like they do a lot. That number is 9.8, and it's a different equation. And that number is really hard to work with without a calculator. So we're going to do like the same concept, but we're only going to do with the nice number 16. So it's feet and seconds. Okay, how do you draw a graph? Well, it's pretty much always going to be in quadrant 1 here. Almost always. Is it x and y? No, let's look at our variables here. It's the t-axis, and it's the h of t axis. So I always want you to put the letters on the axes. The second thing is I want you to label them. So what does t stand for? T stands for time. And after you write what it stands for, I want you to write in terms of seconds, the units. What does the h of t axis stand for? It stands for height. So label it with height. And then in parentheses, tell me in terms of what kind of units? Feet. So that's how you label the axes, with letters, words, and units. And then next comes the graph. Okay? In the beginning of time, what's the initial height? What is the y-intercept? The y-intercept is the initial height. So wherever the initial height starts, it's going to be a parabola opening down. And don't you know about throwing things up into the air? You throw them up into the air, and then gravity brings them back down. So this is projectile motion. And all we're really doing here is a parabola opening down. Okay, Emma fires an arrow straight up from the ground. Okay, straight up from the ground. So her h naught, where is she starting? She's starting on the ground. Her h naught is going to be 0. The initial speed is 200 feet per second. What does that sound like? That's the initial velocity. Its height, after t seconds, is modeled by that fun equation. Okay, let's write the appropriate equation for this arrow. So h of t, it's always negative 16t squared, plus her v naught is 200, so plus 200t. T squared, t, then the constant. And the constant, the time is 0. Now you don't have to write that. I'm just showing people how I plugged in the h naught into the right spot. So this is a parabola opening down. All right, please draw a very labeled graph. So let's take a look at the axes here. We've got the t-axis and the h of t axis. What does t stand for? It stands for time in terms of seconds. How about height? Height is always in terms of what kind of units? Feet. All right, now I have to make sure we start this arrow at the right place. So the beginning of time, when time was 0, where did it start? The initial height was 0. So we're going to start right there with a nice point. It's going to go up, 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 up. It's a parabola opening down, and then it's going to reach the ground again. Okay? It's not burying itself underground, so just put a point and stop when it hits the earth. All right, so if you look at the vertex here, we've got an H, comma K. H represents time, and K represents the height, in case you need to know. The first question says, what is the maximum height? Well, here's the maximum point, and I want the maximum height. So should I find the H, or should I find the K value for height? That's the Y value, so I need to do a K calculation. C is 0 minus B squared, 200 over 4A. 4 times negative 16. Let's see what kind of canceling we can do here. Let's cancel the negatives for sure. Let's cancel 200 by 4. 4 goes into 250. Let's see. Maybe I'll divide by 2 and get an 8. Divide by 2, get 100. I would really like to leave that 100 if I could. I don't know if I'll be able to. Let's cancel 50 by 2. So we'll get a 4 here. 25. It doesn't seem like I'm going to be able to leave. I have to cancel the 100. So 4 goes into 125 times. So 25 times 25 is 625. Now I have to put some sort of units on this. This K. Oh, it's feet. So 625 feet. Wow, that's really high up there. That's a really strong arrow. At what time does it reach that height? Okay, that height, that maximum height, what time? Oh, that's an H calculation. H is going to be negative B, negative 200 over 2A. That's 2 times negative 16. So let's cancel the negatives. Let's cancel 2 and 200. That's 100. Let's cancel by 4. That's 4 and 25. All right, so I've got it down to 25 over 4, and that doesn't cancel. So you can leave it like that, or we can make it mixed. 25 divided by 4 goes in 6 times per, and then there's 1 left over. So 6 and 1/4. And now how about some units for this X value? Seconds. Okay, if you want to leave it as an improper, that's fine. If you want to make it mixed, that's fine. If you'd like to put the decimals down, if you know what they are without a calculator, fine, but don't chop any of them off. Just make sure that this is reduced. And let's get a red pen out for this last one, because this is a tricky one. At what time does the arrow hit the ground? So the arrow starts here, goes up into the sky, hits the ground right here. There's the ground. So should I do an H calculation or a K calculation? What do you think? Well, the answer is neither, people. H and K is up here. Okay, this is the ground. That's way down there. Okay, when you're at the ground, you know what that is? That's an X-intercept. So we're not going to do an H or a K calculation. How do you find an X-intercept? You're going to let Y equal 0. So we have to say 0 equals, where's the equation? 0 is going in for the height, and then the rest of the equation is negative 16t squared plus 200t. All right, the biggest thing is when people are doing this chapter, they go H and K crazy. But if it's hitting the x-axis, that's not H or K. And how do you solve a quadratic? I've already made the 0. Now it's time to factor. So let's see, what can we take out of here? I know I can take a negative out. And I know I could take a 4 out. Can I take out a larger number? I'm not sure. All right, well, let me take out negative 4 and see what happens. because I know I can divide by 4. The negative and the 4 are factored out, so I've got 4. Oh, I probably should take out a t, too. Okay, you could squeeze it in if you think of something else. Take out 4t. That gives us 4t. Positive divided by negative is negative. 200 divided by 4 is 50. And I've taken the t out. Oh, now that I see this, I realize I probably could have taken a 2 out also. But that's okay, because it's not going to really affect our answer. You can now do the zero product property. You could say negative 4t equals 0, or 4t minus 50 equals 0. And even if this was smaller, the number would have been there, it's going to give you the same result. So as long as you factor at least the t out. So here, t is 0, or t equals 50 divided by 4 is 25 over 2. And t is seconds. So why am I getting 2 answers here? Let me look at this picture. 0 seconds is there. Oh yeah, it is on the ground at 0 in the beginning. And the other answer is 25 over 2 seconds. That's why I'm getting 2 answers, because it touches the ground 2 times. I think they were going for the 25 halves answer, but if you write both of them, that's correct too. If you have a parabola like this, how do you find the vertex? Okay, so the vertex is up here. That's the h comma k values. You could either, 1, you could complete the square. Some people are very algebra people. Or number 2, you could always use the h and the k formulas if you're more of a formula person. It also depends on the numbers and stuff. Sometimes the h and k are just faster depending on the values. Okay, if you have a y equals value, so let's pretend you have this parabola, and I want to see when is the projectile 10 feet off the ground. Okay, when is it hitting 10? Well, in this picture here, it's hitting 10 twice. Sometimes the number's so high it doesn't hit it at all. What you would do is you would put 10 equals equation, put 10 in for the height and for the h of t. Then you would have to make 0 equals equation. You have to move everything over to one side, okay, and then you'd have to factor. And since this is an entire unit where I've designed it, it will be able to be factored nicely, so don't worry. Okay, and the last one, the zeros, the roots, the x-intercepts, okay, those are these points down here. Where does it hit the ground? Okay, so that would be 0 equals equation. 0 is the height, and then since it's already 0 equals, all you're going to do is factor. Let's walk through a couple of these here. So we've got a baseball thrown straight up into the air. Its height in feet, okay, so the height is feet after t seconds is this equation. This equation should be very familiar to you, the h of t equation, parabola facing down, the initial height, okay, that's the h naught, and in the h naught place the 5, so let's just say 5, don't forget units, 5 feet. They give you the equation. These first couple questions here are going to be really fast. What's the initial velocity? What's the v naught? 40. Let's say some units here. 40 feet per second. Okay, sketch a labeled graph that represents the height of this ball over time. So if we take a look, we've got 2 axes. We've got the t and the h of t. This stands for height in terms of feet. This stands for time in terms of seconds. Okay, I'm getting the hang of these. How about the initial height? The initial height is 5, so I want to make sure that I show a graph starting at 5. Projectile going up into the air and then coming back down, hitting the ground right there. Okay, nice clear points. Sketch a labeled graph. Okay, that's pretty labeled with numbers, units, and letters. What is the maximum height? Okay, so when I go up here to the maximum, it's at the tallest point, I'm looking for height, the maximum height. So should I find the x value or the y value for height? Since height is on the y-axis, that would be a k value. So let's do a k calculation. I got to take c minus b squared. That's a 40 times a 40. Ooh, all over 4a, which is negative 16. Okay, it's time to do some number work here. Well, the negatives cancel, that's for sure. And how about a 4? A 4 would cancel to make a 10. And a 4 would cancel here to make a 4 and a 10. And then I could divide by 2 to make a 5 here, and the last 2 to make a 5 there. So it looks like I have 5 times 5. So it looks like I have 5 plus 5 times 5 is 25. The magic answer is 30. I could go up here to the k value and put 30, but I need to say some units for this. This is the y value, this is height. The units are feet. 30 feet. So the highest it gets is 30 feet, and then it comes back down to the earth at 0 feet. During what time interval is the ball greater than or equal to 29? It's definitely equal to 29. If I look at this graph, it starts at 5, goes all the way to 30. So 29 is down here somewhere, just below 30. So it looks like it hits 29 on the way up and then on the way down. So how do you find the x values? How do you solve this when you have a y value? We're going to put 29 in for the height. 29 is going to go into the h of t. 29 equals equation. Okay. After you do that, you're going to want to move everything to one side. Let's go ahead and move everything to the left. I want to have a positive 16t squared. That's going to be a negative 40t. Minus 5. 29 minus 5 is going to be 24 equals 0. So I know I have to factor. I'm thinking maybe take a constant out. The greatest number they all have in common is an 8. I think I'm going to take an 8 out, just so the factoring becomes a little smaller, a little easier here. Plus 3 equals 0. Not all problems in life are going to factor this nicely, but like I said, I designed these just so that you could do it without your calculator, so it should work. 2t squared has to be a 2t and a t. Has to be. And the only way to make a 3 is a 3 and a 1. Question is, where am I going to put the 3? I got to make a 5 somehow. Let's see, if I put the 3 here and the 1 here, the outers make 2t, and the inners make a 3t. Well, if they were both negative, that would make a negative 5t, and a negative times a negative would make a positive. Perfect. So it looks like the answers. T equals 1 second, and t equals 3/2, or 1.5 seconds. So let's go look at our graphic here to make sure, does this make sense? So here's 1 second. At 1 second, it's 29. And then 1.5 seconds must be right here. 1.5 seconds, right there. Now it says, during what time interval is the ball greater than or equal? Oh, okay, greater than or equal. So that means I could equal 29 and be greater. Look at all this time. All this time at 1 second, then it's higher, then it's equal to 20, then it goes below. So I don't want to include those pieces, but I definitely want to include all of that. So I think I might use some interval notation here from brackets. Since it said equal, those are closed bubbles from 1 second all the way up to 1.5 brackets seconds. Or if you like, you could say t is between 1 and 1.5 seconds. Just don't forget your units. Either notation would be fine with me. Okay, let's take a look at another projectile motion problem, something we're going to do quite a bit of, so you're going to want to make sure you get a hang of this. Jason, I don't know why you're sitting in a pit 4 feet deep. Let's draw a picture of Jason. Draw a picture. So here's the pit. Okay, and where's my little Jason marker? Jason, he's happy. He's happy to be in that pit way down there. Okay, the pit is 4 feet deep, and he's going to shoot a rocket way up into the air. And he wants the rocket to reach 60 feet high. So that means that this rocket is going to reach up to a maximum. So the 60 is going to be the height. That's the K value. Okay, that's the K value for the height. Write an equation that represents the path of the rocket. Okay, so this rocket, h of t, it starts off negative 16t squared plus, how about the v naught? What's the velocity? Oh, Jason doesn't have a velocity. Alright, let's just say v naught t. Okay, and then how about the initial height? The initial height, oh, he's in a pit? So he's not at 0, and he's not above ground. The initial height is negative 4. Okay, that's interesting because the equation's not complete. What should he make the initial velocity to ensure the rocket's going to reach that height? Okay, we already have a good graph here to kind of get us started. We have a nice visual of it going up to 60. That is the K value. Okay, so whenever you have a question that says find initial velocity, okay, my hint to you is use the K formula. Use the K formula. K equals C minus B squared over 4A. And I know the K, so that's why we're going to use the K formula. All right, give me a K. 60. Give me a C. Well, the C is negative 4. Okay, give me a B squared. Well, the B value here was something we didn't know. It's V naught. V naught. So we're just going to write V naught squared over 4, and the A value is negative 16. Okay, now remember, we're going to do this without our calculator, but don't worry, it's going to be okay. The first thing I'm going to do is add that 4 to the other side. Add that 4 to the other side, so that's going to be 64 equals negative V naught squared over 4 times negative 16. Okay, don't multiply those together. Okay, we're just going to keep everything separate. A negative divided by negative, that's going to cancel out. Okay, and I think what I'll do to both sides, you can think of it like cross multiplying, or you can think of it as I'll multiply both sides by a 4 and a 16. Okay, however you want to think about it, they're going to cancel out. So on the left-hand side, we're going to have a 4, a 16 times a 64. And I'm still not going to multiply those out. This equals V naught squared. So what I need to do is square root both sides. Okay, and this is going to get a little interesting here because there's no plus signs. This is the square root times, times, times. So those can all be taken individually. The square root of 4 is a 2. The square root of 16 is a 4. The square root of 64 is an 8. So the initial velocity should be 8 times 8, 64 feet per second. If only Jason could make that be the initial velocity, then his rocket will reach 60 feet high. How long does it take the rocket to reach that height? How long? So when you're looking at your graph, which we kind of already have here, the x and the y-axis would go something like this. The x-axis is time, or the t-axis, and the h of t was the height. So now they want me to find h. This is an h calculation. H equals negative b, which is negative 64, negative b over 2a, which is negative 16. So let's go ahead and do some fancy canceling. We'll cancel the negatives. Do you want to cancel by 8? That'd be fast. 8 goes into 16 twice. It goes into there 8 times. Cancel the 2 to make a 4. Cancel the 2 to make a 2. So the survey says 2, and I need some units, 2 seconds. So remember, whenever you have a problem that says find the initial velocity, find the velocity, you have to make sure you use the K formula to do that. Okay. Can you solve a word problem with projectile motion equation? Okay, I hope you have that memorized. And can you use algebra techniques to maximize, minimize? So can you use the K?